The next lesson in this unit will be on rational exponents. We're going to write radicals in exponential form using rational exponents. Then we're going to switch it, and we're going to write things with rational exponents in radical form, and evaluate the expressions and simplify. So this diagram shows that b to the 1 over n power means that if you had a base b written to a rational, when I say rational, I mean it's a fraction. You can see it's 1 over n. Then you can rewrite it. If you have b to the 1 over n power, then you would write it as the nth root of b to the first power. And so right here it shows you that 27 to the 1/3 power is the same thing as the cube root of 27 to the first power. 27 is 3 times 3 times 3, so that would be 3. Now, if you did negative 16 to the 1/2 power, that's the same thing as taking the square root of negative 16, which is not real and is indeed 4i. So here are some examples that I have written. We have the square root of x to the first power, then you would write it x to the 1/2. So that's just another way of saying that I'm taking the half root of x. All right, so if I have over here, if I have x, the cube root of x to the first, that would be x to the 1/3 power. This one down here would be x to the 2/3 power. So you can see that it goes 2, then 3, 2/3, inside then out. So this one, if you're using the same thing, would be x to the 3/2 power. And you can see here that if you took the square root of x to the 3rd, right, you would have an x that would come out, and you would have one that stays in. And we're going to assume now that this would always be a positive answer, so we don't have to put the absolute value. But then if you had one like this, x to the 2/5, right, you write the radical sign, put the x on the inside, and it would be 2 and then 5th. So in order for the x to come out, I would have to have 3 more of them, because I only have 2. So here are some other questions. These should be pretty simple to do. If you have a to the 1/7 power, that would put an a on the inside, 1/7. So it would be the 7th root of a, is how you'd write it. If I have the square root of w, that would be w to the 1/2 power. A to the 1/3 power would have an a on the inside. It would be the cube root of a. And then if I have this one, I have x to the 1/5 power, and that's the 5th root. So here are a few more, right? If I have 25 to the 1/2 power, that's the same thing as the square root of 25, which is 5. Over here, I put the 27 on the inside. This would be to the first. I don't always write that. And then 3rd. Well, remember that this is 9 times 3, which is 3 times 3 times 3, right? So this is just 3. So what's 36 to the 1/2 power? Well, it's the square root of 36, which is 6. So then, once you understand that concept, then the rest is just adding to it. We're just adding more layers. So for instance, if I have this first one where it says 25 to the negative 1/2 power, well, we remember that negative exponents mean that you write it 1 over, right? It was in the numerator, now it's in the denominator, positive. So this is 1 over the square root of 25, which is 1/5. Okay, this one down here, the 4th root of 100 would be 100 to the 1/4 power. Now, you could write that a different way, right? Isn't 100 10 squared? Right? So you could combine those, and you could say that this is 10 to the 2/4 power, or 10 to the 1/2, So that this, if you rewrite it back, is the same thing as the square root of 10. So the fourth root of 100 is the same thing as the half root of 10. All right, then over here, this is evaluate. It's real blurry, but just write it like this. You have 16 to the 3/4 power, right? Well, what is 16? It depends on how you do this, right? But if you do twos, right, if you say, well, let me write it this way. This will be easier. Write it here, put 16 on the inside, and put here and there. So it's the fourth root of 16 to the third power, right? So if you think about that, that's 16 3 times. So 16 times 16 times 16. Still not a group of 4, but that factors. So 4, 4, 4, 4, 4, 4, right? So here's a group of 4. And then we know that 2, or 4 is 2 times 2 times 2 times 2, right, like that. So this would actually be, this 4 comes out, the 2 comes out, that answer is 8. So they're kind of like regrouping. You just regroup the numbers into the different roots, and you have to kind of think about what you have. So the first thing was to write it in a radical form, and the rest was to simplify. Okay, so here's a couple more examples that would be really interesting. So remember that when you multiply two numbers together with the same base, right, then you add their exponents. So this would be x to the 1/5 plus 2/5 power, which is x to the 3/5, which would be x to the third fifth root. And that's all you do with that. Then this one is negative. So once again, you're going to do 1 over, and then I'm going to have x to the 2/3. And that's it, unless you want to rationalize it. And to rationalize it, remember it's the third root, so I just need one more to make that come out without a radical. So do this on the top. And so this will be the cube root of x over x. So on this one, what you could do, you've got the sixth root of 4x to the 4th. So I'm going to write them separately and see what happens. So I have 4 to the 1/6 power, and then I have x to the 4/6 power. Well, we know that 4/6 reduces to 2/3, so I could do x to the 2/3. I also know here that 4 is 2 squared. So I would say 2 squared to the 1/6. Well, that would be 2/6. What is 2/6? Well, it's 1/3. So I've got 2 to the 1/3, x to the 2/3. So if you rewrote that together, they would both have the third root 2x squared. So in other words, this with the sixth root is going to be this with the third root. And all you're doing is just messing around with the fractions. Okay, so let's do this one down here, and they're backwards, and I don't know why. But the top would be 4 to the 1/4 power, and the bottom would be 2 to the 1/2 power. But we remember that 4 is 2 squared, right, to the 1/4 power. I'm just going to leave this like this. So this is 2 to the 1/2 power over 2 to the 1/2 power. Guess what that is? 1. So I'd like you to write these two problems down in your composition notebook as you're taking notes and see if you can figure out how to simplify them just like what we did on the previous screen. We're going to be practicing these a lot. And thankfully, you're all very good at fractions, so this is actually going to be quite fun. So I look forward to seeing you in class. Write these problems down and try them, and I will see you then.